one of the most important elements of data analytics would be data visualization. So far, you have learned how to basically use Python to create programs or simple applications actually. But what we're going to look at today, we've also looked at how to use NumPy and Pandas, which are two libraries that allows us to manipulate data within Python. But what we're going to look at today is how to create actual visualizations. So here, I'm going to start off by first putting a little heading, font color equals font color equals red and bold, and I'm going to put data visualization. Close this off. Now, there's a very specific reason why I actually did this here. And that is because when you are doing, so there are a lot of different types of coding, right? One type of coding that you would find, not necessarily what we would consider programming, but one type of coding that you would find is what is known as web programming. In web programming, oftentimes instructions are within what we call tags, and these are tags. So oftentimes if you look at any website, like for instance you want to get to the source code of a website, the HTML, whatever the case may be, you would see these tags over here. And the reason why I do that is because in a bit we would actually start looking into web scraping, and understanding these tags is important. So anyways, in Jupyter Notebooks it allows you to do something like that if you would like. Now, in order for us to use, or in order for us to do data visualization, there are three packages or three libraries that we're going to work with. One is Pandas, obviously, because we're going to import data sets. So import Pandas as PD. We also want to import matplotlib. Now, matplotlib is kind of the de facto Python visualization tool. And if I'm being honest with you, it's not the best tool in the world to use, but it is something that can be relatively straightforward, sort of. So there are many different types of, I guess we can say sub-packages of matplotlib. The one we're going to focus on is matplotlib.pylab as a PLT, and import Seaborn as SNS. Now, I give these acronyms PD, PLT, and SNS. I give these acronyms. I can use anything I want. I can call this P1D if I wanted. However, the reason why I use this is because oftentimes as data analysts or data scientists, they just tend to use these acronyms because they're the best or easiest acronyms for these packages. You can use anything you want, as I said. You can call this SB, for instance, but you would find a lot of code would usually use these packages in and of itself. It's not a rule for Python. It is just simply it's an unspoken norm within the programming or the data science community. So we need these three packages. You can see this is clearly running over here. Once we're done with that, then I need to actually import my packages. So I'm going to import a data set known as Amtrak, and basically that data set will be uploaded for you. pd.read_CSV, and from here it's just Amtrak.csv. Once I'm done with that, I want to print Amtrak.head. Let's do just 5 of it, just to see what it looks like. And I also want to get some information as to what this particular data set looks like. So amtk dot info. All right, so if we look at it, there are two variables. One is month, one is ridership. Month, which happens to be an object, and ridership, which happens to be a float. But the thing about it is that month is really and truly supposed to be a date data type. So I want to go ahead and convert that. So I'll do amtk, that's how I wrote it, month is equal to amtk month as type date time 64, which is the data type for essentially this is the data type for essentially pandas date time. There's another thing that we could also try, so up to you, whichever one you feel better using. We can do amtk month. Now the reason why I'm putting it in quotations is well, as a comment, is because I could only run one of it. So you can do this if you want as well. pd dot to underscore date time amtk dot month format equals, and you would do percent day slash percent month slash percent year. So once I'm done with that, I'll just do amtk. I want to rename this column into month. I want to rename month into dates. So amtk dot rename columns equal, and from here I do these squiggly brackets, month colon dates, and then I want to just see amtk dot info. So now let me actually run this one first, and then I'll run the reason why I personally prefer this type. So let me run this first, and we can see how it changes it to date time. Okay, that was my bad. It's date time. Okay, so now let me run this, and you would see that it's essentially now a date time. Let me run this back again. All right, so back once more, it is simply an object, and let me do this and do this. And the reason why I prefer this method is because technically you can change any data type just using this code rather than having to do this. However, sometimes you may need to do this given the fact that essentially it allows you to fix the format in and of itself. So we can go ahead and do a simple print of amtk dot head. All right, we can see that it's basically all the same dates as we had before. All right, all the same dates. It's just that it changed it up a little bit for us. But it's still dates, more or less. And then from there, there's another data set that we're going to work on, which is the Boston data set. So there are two data sets that we're going to work on for data visualization, Boston housing, and we already did this one, which is the Amtrak data set. So for this one, I'm going to just call it BOS is equal to pd.read underscore CSV and Boston housing.csv. So these are the names of the files. If you change the names of the files, then obviously the what you write inside of there, how you call upon it, will be different. So once I'm done with that, I want to print boss.info, right, just to see what it looks like, and also print boss.head, and we'll just do a small bit of it. So it's a pandas data frame. There are 13 variables over here, and we can see what these variables look like. Now, just to make mention of what these variables are, so these variables that we're using are basically this crime. These are Boston housing. These are basically values for Boston housing. CRIM is the crime rate. ZN is the percentage of residential land owned. Residential land zoned for lots over 225,000 feet. So this is a percentage. Crime rate is whatever the crime rate is. Index, percentage of land occupied by non-retail business. CHAZ does the track bound Charles River. 1 if track bounds the river, 0 otherwise. Okay, so this is something that we should pay a little bit of attention to. NOx is the nitric oxide concentration. RM is the average number of rooms per dwelling. Age is the percentage of owner-occupied units built prior to 1940. DIS, the weighted distance to 5 Boston employment centers. RAD, index of accessibility to radial highways. Tax, full value property tax over $10,000. PT ratio, pupil to teacher ratio by town. LSTAT, the percentage of lower status of the population. MEDV, which is the median value of owner-occupied homes in thousands, so basically the median value of the homes. And CAT.MEDV is the median value of homes, owner-occupied homes in tract above 30,000. So 1 if it is basically over 30,000, or if it's less than 30,000, it's a 0. So the reason why I brought this up is we can clearly see that all of these variables here, they're numeric, or how to put it, they are continuous variables, right? They can be numeric or integer. But CHAZ and CAT.MEDV are both categorical variables. So given that they're both categorical variables, that is something that we need to change in our data. So we'll go ahead and change it. But before I do that, I actually want to rename this cat.medv because it doesn't really, I don't really like it. I don't really like the space between it either. So I'll do boss is equal to boss.rename and columns equal squiggly line. So cat dot and put a space there, medv, and a colon, which case I'll just name it cat underscore medv. Because this makes it easier for me when I'm coding, because if I try to use this multiple times, there are possibilities of me getting a lot of errors. Never have spaces in your variables. For the most part, you cannot create a variable with a space, but if it gets imported like that, there's nothing you can do. So what you can do is you can try to rename it so that it doesn't cause any conflicts later on. The next thing is I need to change these into an object type because they're categorical variables. Cat underscore medv is equal to boss cat underscore medv dot as type, and we'll make this an object. And I'm going to do the same exact thing for CHAZ. So CHAZ equals boss dot CHAZ as type object. So see, this is the reason why I prefer this line of code rather than using this to datetime, because it just allows you to do it for any particular data type that you want to change. So what I'm going to do now is I'm going to do a quick print of boss dot head, and let me do a quick print over here, and let me do boss dot info, and all of this should basically be in a print. And I have an invalid syntax. This dot here should not be there. Okay, my bad. So here I can clearly see that I have the same values that I had before. All right, nothing changes here. But here I can see that, okay, this changed to object and this changed into an object, which is basically changing this from an integer to an object. This was also integer. We changed it into an object. So this is my data preparation. Now, once I'm done with data preparation, then I can go ahead and do my data visualizations, which I'll start with the first visualization in the next video.